Okay, so today we're going to go over quantitative single sample confidence intervals by Arjun Nichani, Daniel Begg, Ivan Rodionov, and Vidar Ravindra. Okay, so you have to meet some conditions before you actually go forward with the numerical calculations for your test. So you have to meet the random condition where data comes from a well-designed random sample or randomized experiment. And then if you're sampling without replacement, you need to check that the sample size is less than 10% of the population, which is also called the 10% condition. You have to, if you're using proportion intervals or a z interval, you have to check that both n times p hat and n times 1 minus p hat should be greater than 10. And then if you're using mean intervals or a t interval, you should check that your sample size is greater than or equal to 30. If it isn't, if it's less than 30, then the distribution of data must be normally distributed. To interpret it, you just say that we are your confidence level, confident that the interval from blank to blank captures the true, and then your parameter and context. Now, your four-step process. So we want to state what the parameter we're going to estimate, and then you're going to state your confidence level. Then you're going to do the plan, your inference model, so a z interval or a t interval. Check your conditions, so random, 10%, large counts, or normal / large sample. And then you need to include context for your conditions. And then for do, you can find the interval using your calculator or by calculating with the equations and the tables, and then conclude in context like we did before. Okay, so formulas. The general formula for confidence intervals is statistic plus or minus critical value times standard deviation of the statistic. Proportion intervals, it's p hat plus or minus z star times square root p hat times 1 minus p hat over n. For mean intervals, it's x bar plus or minus t star times standard deviation over square root of your sample size. For mean confidence intervals, your degrees of freedom must be known, and they're n minus 1, and you should always round down if your value is not on your t-table. You should never round up. Okay, other information, you should know that lowering the confidence interval lowers the margin of error, which is this part. And then you should also know that the critical value from table A, which is for z's, and t-table, table B for t's, is both found on the formula sheet on the AP exam. You can use it on the calculator, which we will show now. Okay, so now we're going to go over how to do a t interval and a z interval, which are one sample quantitative confidence intervals on your calculator. So here we're doing a TI-84. Okay, so let's say we're going to do a proportion interval. So we're going to go to z interval here. And then there's data, which you can input data yourself, but we're going to go to stats. Here, this is a standard deviation that you're given, let's say 14. This is your observed value of count, so let's say 22 here. N, which is your sample size, so 37 here. And then confidence level, which is 0.99, which is 99%. Calculate, you get your confidence interval, your x bar value you put in, and your sample size. And this is what you're going to use when you do your conclude step. So now for t interval, same thing, stat, test, t interval, then you can same thing, data, but we're doing stats. Your average sample mean, your sample standard deviation, which we'll put as 7, your sample size, which here is 37, your confidence level, which is 0.99, 99%. That's your confidence interval. That's the sample mean that you saw. That's your sample standard deviation. That's your sample size. And this is what, again, you use on your do step and in your conclude step. We hope you learn from this and ace your finals and your AP tests.